Hey guys, my name is That Quiet Kid, and in this video, I am going to cover a privilege escalation topic, that is capabilities. So, what are capabilities? So, capabilities, you can say it's a way to break the root permission into smaller, more specific permissions. So, instead of giving, full control or root permissions, we only assign it capability that it truly needs, which makes it more secure. So even though it is used to make the system, the binary or anything that has these capabilities more secure, it can still be exploited. So in this video we are going to see how. So let's log in into the system. SSH cape1 at the rate 192.168.1.114, and cape1 is the password as well. So in order to find or list all the capabilities in the system, we can use get cap dash r slash 2 slash dev slash null, which is to basically discard all error messages to dev slash null. Press enter. So we have got a lot of capabilities, but the ones that we can exploit and we are going to cover in this lab are these four. So let's start with cap deck read search. So this is a capability which allows you to bypass file permissions to perform read write operations on files and directories. So if you have this capability, you can read any file on the system even though you don't have root permissions. So how do we exploit this? We can see that we have this capability on tar, which is used for archiving files. So we are going to archive a root file and then extract it and read it. So if you do ls-la, you will see that there is a file name as root file, and it's in the current users directory, that is cape1. So we have a root file which has read write permission for root users and read for group, but the rest of the users cannot read this file. If you try to read it, you will get this permission denied error. Okay, permission denied. So how do we exploit it? So let's use tar dash c. We are creating an archive dash z and dash f. So z is basic, that z option is basically that we are using gzip, and f is to name the archive. So let's name the archive temp slash, I'm using temp because I am putting it into temp folder. Temp slash, let's name it root file dot tar dot gz, and the file we want to archive is root file dot txt. Navigate to slash temp. We have this archive. Now let's extract the files. Tar dash x, x is to represent we are extracting a file. C was we are creating an archive. So dash x, v is for verbose, that if you get any error messages show me, and f is to name of the file. So the name of the file is root file dot tar dot gz. Press enter. Okay, we have successfully archived this file. Now if you try to read it, we can see that we have successfully view the content. We have successfully viewed the contents of root file.txt, which was password for root user is tour. So if you switch user to root, password is tour and id. So we successfully escalated our privileges to root user by exploiting the capability cap deck read search. Okay, so in, it's not always going to be a file in your folder which you find and archive it. Usually in a scenario you will try to zip that etc slash shadow file. So let me open up another terminal. If you try to read etc slash shadow file, you will see that permission denied. So etc slash shadow file is a file in Linux which contains hashes of all the users. So what you would do in a scenario is during a CTF or a engagement, what you can do is you can try to zip this etc slash shadow, and I mean tar, using tar you can archive it and extract it and read that etc slash shadow, where you will find a hash, and using hashcat or John you can crack them. Why I'm not doing that in this lab is because I already used that etc slash shadow to show a scenario which was misconfigured file permissions in video 1. So that's why I'm not showing it in this scenario. So that's for cap deck read search capability. Now let's move on to this cap set uid plus ep. So let's exit out of here. Let's switch user to cape2 and the password is cap2 as well, id. So we are as cap2 and let's try to read the capabilities. So now we are targeting this cat set uid. So what is cap set UID? So this is basically, you can say, it's a capability which allows a program or a process to change its UID to root user. So if this is set on a program, it can change its user identity. So we are going to use this to escalate our privileges to root user, and this is set on an instance of Python in the current folder of cap2 user. So navigate to I think we are already in cap2. No, we are in temp. So navigate to home slash cap2, and you can see that there is a Python instance here. So using Python, because this Python instance has this capability of keep set UID EP. So we are going to use this instance of Python to escalate our privileges. How we can do that? Simply go to your browser and navigate to GTFO bins. Select Python, and you will see there is a capabilities function as well. So it says to simply execute like import os and then execute this os.setuid, which is going to set the user id to root and spawn a process bin bash as that user. So instead of not bin bash, it's sh. So instead of sh, we are going to do bash because bash is more friendly. So simply copy this from here. So show the like use the whole path, that is home slash cape2 slash python 3 and the command. We are importing os, we are running an os command to set uid to the root user and spawning a sh shell, but instead of sh let's spawn a bash shell, right? Okay, now do id. So we have successfully set the uid to root user. So that's how we exploit cap set uid capabilities. So now we have to move on to another capability, that is cap sysadmin. So let's exit out of here, switch user to cap 3 and clear the screen. Navigate to slash home slash cap 3 directory, and we are exploiting cap sysadmin capability. So what does this cap sysadmin capability means? So this is a capability which allows a process or a program to perform admin tasks. So if this is set on a program that we have this Python instance, if I do ls-la, you will see a Python instance, and this Python instance has that capability which will allow it to perform admin tasks. So we can first let's go to the browser and navigate to Hacktricks and search for cap sysadmin. So click on cap sysadmin. So what we can do is, if this is set on a in this case it is set on a Python instance that is located in our current folder, what we can do is we can create a copy of the password file in our current directory we are going to create a password, I mean a password hash. Then we are going to mount that our own created password file on the etc slash password, so that whenever the cat etc password file is exist, it will display the contents of our password file. So we are mounting the modified password file on the system's etc slash password file. So what we are going to do is first copy paste slash etc slash password to this current directory. If you do ls-la, we have the password file. So now we are going to use OpenSSL to create a hash. OpenSSL password dash 6 is for SHA-512 hash, dash salt as root 2, and the password for password, let's say it's easy root. We have the hash. Now let's copy it. Let's modify the nano using nano the password file. Press enter and let's create a user called as root2. Put in the hash 0 0 root 2 slash let's name it root 2 slash bin slash bash. Now cat out the password file. We successfully added a root user. So what we are going to do is now we are going to mount this password file on the etc slash password file. So how we can do this? Using the code that they have provided. So just copy this code. Let's name it nano exploit exploit.py, because Python, we have the capability set on Python instance. Now modify the location to home slash cap 3 slash I think it was in this folder, right? Cap 3 slash password. Yes, exit out of here. Now using the Python instance we have here, which is slash home slash cap 3 slash python 3 and exploit dot py. Okay, now when we try to switch user, it is going to access our own password file instead of the system's password file, which is located in etc slash password. So switch user to root 2. The password is easy root, which we were just set, and to id. So we have successfully escalated our privileges by exploiting the capability which is sys cap sys admin. So we can navigate to the root directory as well. Yes. So that's how we escalated our privileges to root by exploiting the third type of capabilities. So if you clear the screen, exit out of here. So now we are going to exploit the last capability, which is cap sys module. So what does this capability does is it allows a process or a program to load or unload a kernel module. So we can insert, modify, delete any kernel module by bypassing the restrictions. But I have made a few changes to the lab. So instead of using Python, we are going to be using kmod. So let me first run the command get capability slash r slash dash r slash to remove all the error messages to dev null. So you will see that there is another binary which has the capability set. This one, this bin slash kmod. This kmod binary is also used for managing kernel module. So we are going to use this binary to exploit and gain root privileges. So what we can do is we are going to create a kernel object, and such that whenever that kernel module whenever that kernel module is loaded, it will execute our reverse shell. So there are few conditions to check. First, let's navigate to Hacktricks and search for reverse shell. We have found this reverse shell. Copy it. Let me first check which user I am running as. So I am already running as cap4 and pwd. We're in cap4 as well. So let me use nano command to create this reverse shell dot c. Paste the IP address, which in my case is 192 dot. This is the IP address of your machine on which you want the reverse shell 1.11, your attacker machine, Kali in this case. We have successfully created the reverse shell, but there are a few things to do first. So whenever you create kernel module, or you load a kernel module, there are a few dependency checks that there is a command called as mod probe. So that command basically checks for the dependency. So we'll have to create our own dependency and libraries first. To do that, run the command make dir dash a make dir library lib slash modules dash p. We have this. Okay, so now we are going to copy paste all the libraries into our own fake created directory that we have just created. Why is that? Because whenever we load or unload kernel module, there are some dependency checks that are done by mod probe, so we have to check for those as well. So to copy paste, use cp slash a and slash lib slash module slash dollar sign. There is a command uname dash r, which basically is this. Using this command you can get the OS operating system's kernel version. So we are copy pasting to lib slash modules slash dollar sign uname dash r. Okay, so press enter. It will take some time. We have our reverse shell and we are going to copy this make file. So what we are doing here is using that reverse shell, we are creating a kernel object. So let's create that make file. So when I was simply creating that kernel object, I faced some errors because of spaces. So what you can do is remove the spaces, press enter and use tab instead of manually adding spacing and adjusting. So do this, use tab and press enter. So when you run the make command now, it will build our kernel object, and that kernel object will be injected when we load or unload a kernel module. So simply run make, it is executing, and if you do ls, you will find this reverse shell dot ko, which is our kernel object, which will be injected when our kernel module is loaded. So there is a command called as insmod, which basically insert when we will execute this insmod command or this reverse shell.ko, it will insert the kernel module, which is internally using our kmod command. So kmod command is basically injecting internally. So when the because our kmod has those capabilities, so when I use the insmod command and load this kernel object, our kmod will internally be executed and basically giving us the reverse shell as root user because it has that capabilities. So insmod reverse shell dot ko, and you have to listen for that reverse shell as well. Okay, so now we are going to use this insmod command to load this kernel module using this kernel object. As soon as we do that, we should we should receive a reversal as root. I think we should. Yes, we have. Due to ID, who am I? So we have successfully escalated our privileges by loading a kernel module. We created our own kernel object which was created using a reversal. So in this way, if you have this cap sys module capability on the kmod binary, we can escalate our privileges to root user by loading a kernel module. So that's it for this video, and thank you for watching.